Hey there, and welcome to this explainer. Look, if you've ever felt that absolute knot in your stomach the second you open a math textbook, I totally get it. Take a deep breath. You are exactly where you need to be. Today, we are absolutely not going to memorize confusing formulas, and we aren't getting lost in a sea of letters and numbers. Instead, we're going to look at some pictures. That's right. We're going to explore algebra purely visually, step by step, in a totally safe, relaxed way. So sit back, relax, and let's demystify linear equations together. So here's our roadmap for today. First, we'll look at math in real life. Second, visualizing linear equations. Third, an easy example called crossing the lines. Fourth, a medium one with bees and flowers. Fifth, a hard one on measuring land plots. And finally, number 6, a cheat sheet and a really cool trick. All right, let's jump right into section 1, math in real life. Now, this is the ultimate question, right? When am I ever actually going to use this? It is such a valid thing to ask. I mean, when you're staring at an equation like 2x plus y equals 5, it feels completely disconnected from reality. But what if I told you that you've probably solved problems exactly like this in your head, without even realizing it? Our source materials show us exactly where these equations live out in the wild. Imagine you're out shopping for notebooks and pens, and you're trying to figure out the individual cost based on the total on your receipt. Or maybe you're measuring a rectangular plot of land for a garden, or trying to understand how potato and tomato prices are fluctuating at the market. Even figuring out the best phone data plan, or designing a building relies on this exact math. These aren't just dry math problems, they are everyday life puzzles that are just wearing an algebra disguise. Moving on to section 2, visualizing linear equations. Okay, let's dive into this. Whenever you see an equation with two variables, an x and a y, it really just means there are two unknown things. And on a graph, those unknowns just create a straight line. So if you have a pair of these equations, you just have two straight lines. Picture them drawn glowing on a dark background. Now, how can two straight lines interact on a flat piece of paper? Well, there are really only 3 logical possibilities here. 1, they cross each other at a single, exact point. 2, they run perfectly side by side like train tracks and never ever meet, which means they're parallel. Or 3, they lie exactly on top of one another, which means they are coincident. And that's it. That is literally the entire foundation of this whole topic. Now, math textbooks love throwing fancy words at us, but let's just translate them into plain English. If the lines cross, or if they lie exactly on top of each other, it means they share at least one point. We call these consistent equations. It just means they have a solution. But if the lines are parallel and they never ever meet, they have absolutely 0 solutions. We call those inconsistent equations. Honestly, it just means they don't agree. They can never find common ground. All right, deep breath. Section 3, easy, crossing the lines. Whenever you feel that exam anxiety creeping up, I want you to rely on this super simple rhythm. Identify, then solve. First, read carefully. Second, identify what equations you're actually given. Third, ask yourself, okay, what is this question actually asking me to find? And finally, solve it graphically. This rhythm is so incredibly reliable. Let's actually apply that rhythm here. So we're given 2 equations, 2x plus y minus 5 equals 0, and 3x minus 2y minus 4 equals 0. All we do here is create a little table for each one. You just plug in a really simple number for x, like a 0 or a 1, and see what y turns into. Then we plot those points. Picture a little animation in your head where these coordinates pop up one by one on the graph and connect to form 2 straight lines. Notice how they neatly cross at one specific spot? It's the point where x is 2 and y is 1. That intersection point right there is our one unique solution. It's the exact spot where both equations are perfectly happy. Let's see how this builds. Section 4, medium, bees and flowers. Okay, so we've got a classic word problem here. It goes like this. In a garden, there are some bees and some flowers. If one bee sits on each flower, one bee is left without a flower. But if 2 bees sit on each flower, one flower is left entirely empty. Find the number of bees and flowers. All right, first things first, let's say bees are x and flowers are y. That first sentence gives us our first line. The number of bees equals the flowers plus 1 extra. So x equals y plus 1. The second sentence gives us our second line. If you group the bees by 2's, so x divided by 2, it equals the flowers minus 1. So x over 2 equals y minus 1. We just plot the points from these two simple statements, draw the lines, and look exactly where they cross. They intersect perfectly right at 4 on the x-axis and 3 on the y-axis. So boom, there are 4 bees and 3 flowers. Visualizing it first makes the whole puzzle just fall right into place. Now, putting my tutor hat on for a second here, I've got to point out where students almost always stumble under exam pressure. The absolute most common mistake is skipping that very first step. You must clearly write down, let x equal bees and let y equal flowers. If you don't do that, I promise you're going to confuse yourself halfway through. Another huge trap is mixing up the conditions or forgetting negative signs when translating English words like leftover or empty into math symbols like plus and minus. Take your time with the translation. It's honestly the most important part of the whole problem. All right, you're doing great. Section 5, hard, measuring land plots. Now, what's really interesting about this slide is how we can take what looks like a terrifying board exam level geometry puzzle and just melt it down into 2 simple intersecting lines. The problem asks for the length and breadth of a rectangular plot. We know the perimeter is 32 meters. Well, perimeter is just 2 times the length plus breadth, which gives us our first equation, length plus breadth minus 16 equals 0. Then the second part says, if the length increases by 2 meters and breadth decreases by 1 meter, the area remains the exact same. Area is just length times breadth. And you know what? When you actually write that out, the scary length times breadth part actually completely cancels itself out. You're just left with a nice, clean second equation. You plot your 2 lines, and beautifully, they cross right at x equals 10 and y equals 6. So the original length is 10 meters, and the breadth is 6 meters. We literally just conquered a terrifying word problem by drawing 2 simple lines. How cool is that? And finally, we made it to Section 6, cheat sheet and trick. This right here brilliantly illustrates the core logic of the entire chapter all in one clean table. So every equation has coefficients. Those are just the numbers attached to the x and the y. Let's call the numbers in the first equation a1, b1, and c1, and the numbers in the second equation a2, b2, and c2. Just look at the relationships here. If the ratio of the a's doesn't equal the ratio of the b's, the lines are going to intersect. One solution. If all 3 ratios are exactly the same, it's literally the same line sitting right on top of itself. Infinite solutions. And if the a's and b's match, but the c's don't, the lines will be parallel. Absolutely no solution. So here is your 5-point cheat sheet. When you're facing a pair of linear equations, 1, check the a1 over a2 ratio. 2, check the b1 over b2 ratio. 3, compare them. 4, check the c ratio only if the first 2 match. And 5, use our table to match it with the graph type. And hey, check out this surprise trick for exams. If a multiple choice question just asks you how many solutions a pair of equations has, or if they're consistent or not, you don't even have to draw the graph. You can completely bypass all that work. Just look at the coefficients, make your fractions, compare them in like 30 seconds, and you've got your answer instantly. That is a massive time saver. As we wrap up this explainer, I really want to leave you with a thought. We started out today with intimidating equations, and we completely solved them just by turning them into pictures of lines simply crossing each other. Once you realize that a mathematical formula is really just a hidden picture waiting to be drawn, it kind of changes everything. It makes you wonder, what other complex, overwhelming problems in your life could you solve by simply changing how you look at them? Thanks so much for hanging out with me today, and hey, keep looking for the pictures behind the problems.